Hi again, 8th grade. This is my last video for this week. Just know that this video is going to be in two parts. So we're going to do one part of it this week and the next part of it next week. So we're going to be learning how to draw Lewis dot and Bohr models. So just as a refresher, because we're going to need to know what these things are in order to complete this, how do we find the number of protons? Well, remember, we have to look at the atomic number. How do we find the number of electrons? We need to look at the atomic number, or you can just say it's the same number as the protons because that is true for this case. How do we find the number of neutrons? Well, that is the atomic mass minus the atomic number, so the big number minus the small number. Where's everything located in our atom? Where are protons found? They are found in the nucleus. Where are neutrons found? They are also found in the nucleus. And then our electrons, they are found outside in a cloud or rings. So when we look at them, we're going to look at them as being in rings around our nucleus. So we are going to be looking at two different models you already see on there. I forgot to put a transition on there. We're going to be looking at this one. This is called a Lewis dot model. So we're going to draw atoms two ways. First one, Lewis dot. That's what we're going to be doing this week. Well, it's more so you guys are going to be learning about them this week. And then next week, I'm going to have you draw them. And then this is our other type. This is called a Bohr model. So the reason why I chose to do the Lewis dot one this week is because if you know how to do this, it'll be pretty easy to figure out how to complete a Bohr model. So a Lewis dot model is, in a way, a simplified version of the Bohr model. So I wanted to start with the simple, and then after we know how to do that, then maybe get into the harder one. So, like I said, they're kind of the same, but our Lewis dot only shows valence electrons. Our Bohr model over here, it's going to show all of the electrons that are in that particular element. This is only going to show the valence electrons, and it's going to be easy because the most valence electrons that an element can have is 8. So you're not going to have to draw anything more than just 8 little dots. So, valence electrons. We know what electrons are, but what are valence electrons? So, valence electrons, those are the electrons that occur in the outer energy level, and these things can participate in interactions with other atoms or other elements. So, each atom has a certain number of valence electrons. In order to find out how many valence electrons something is going to have, we are going to look at the group number that that element falls into. So it's going to be pretty straightforward when we're talking about groups 1 and 2. It gets really wonky after we talk about groups 3 through 18. But just know, for when we are doing this, we are going to ignore groups 3 through 12 in the lanthanide and actinide series because those ones can have different numbers, and I want this to be very straightforward. So, and just know that outer energy level, that's going to make more sense when we talk about Bohr models because there's going to be different rings that go around each element based on where they fall in the periodic table, but we're just going to worry about how many electrons we need to draw around our element here. So, when we are looking at the periodic table, remember groups run up and down. So group 1 is going to have 1 valence electron. Group 2 is going to have 2. You're going to skip 3 through 12. And then for 13, it has 3. 14 has 4. 15 has 5. 16 has 6. 17 has 7. And then 18 has 8. And I will say, and this is going to be kind of tricky to remember, but just because helium falls in group 18, look at how many electrons it has. It only has 2 electrons. So how can it have 8 valence electrons if it only has 2? So just know that helium is only going to have 2 valence electrons. Neon down to oganesson are going to have 8. So it literally just goes 1, 2, 3, 4, 5, 6, 7, 8, except helium, which is a joker. Alright, so knowing how many valence electrons are in each group now, we need to know that, like I said earlier, they can have up to 8 valence electrons. So with Lewis dot models, you only need to draw up to 8 electrons if it's in the 18th group. With Bohr models, you're going to need to draw more electrons. So this is a thing called the octet rule. So this is when atoms want to complete an octet. So it wants to have 8 electrons in their outermost shell. So think back to our groups now. And this goes along with how reactive some of the groups are. So group 1 and 2, remember, they are very reactive. They want to give away their electron because it's going to be easier for them to give away 1 or 2 electrons than receive 7 or 6 electrons. Group 7 is also very reactive because it just needs 1 more electron to fulfill its octet. So it wants to receive electrons because it's going to be a lot easier for it to receive 1 electron than for it to give away 7 of them. And then group 8, this is non-reactive. It does not want to interact with any other elements. Their octet is fulfilled. Remember I said they're the noble gases. They are too noble to interact with another element. And I'm sorry if I wrote here like group 7, group 8. That's what I'm used to writing down, but please know that this is group, let's see, I need to use this drawing tool, so group 17 and group 18. There we go. So group 17 and group 18. Alright, for our Lewis models, this is how you are going to draw them. Remember, they only show the valence electrons, so you're only going to draw the most 8 electrons around it. So you're going to write the element symbol in the middle, and then you're going to put dots around it to symbolize the valence electrons. So there's going to be a way that you should draw the electrons in, and I will show you that when we get to some examples. I'm going to get rid of these lines. There we go. So here are some examples for us. First, we're going to go with beryllium. I tried to include a periodic table on here so that way you can see how many electrons it has. So beryllium is Be, so on our periodic table, Be is in group 2, so that means it's going to have 2 valence electrons. So here's my drawing tool. I'm going to make it a bit bigger, so that way I have electron size, and I'm going to draw the electrons blue. Okay, so beryllium has 2. So when you draw it, just know that, let's say I have Ne, and I don't remember if this is an example or not, so if it is, then we'll just ignore it. But Ne, it's in group 18, so it's going to have 8 electrons in it. So when we draw it, we're going to put 1, 2, 3, 4. So there's 4. And then you're going to draw any other ones, like if you have 5, 6, 7, 8, you're going to draw it just right next to that other one. So you don't need to space them all out, just draw them right next to it. So 5, 6, 7, 8. So going back to beryllium now, it only has 2, so I have 1, 2. All right, My next example is carbon. Carbon has 6, so for carbon, we just need to do, carbon is in group 14, so it's going to have 4 valence electrons. So I'm going to draw 1, 2, 3, 4. And then my last one, I have neon. So let's skip neon. I'll redraw it over here. So this one has 1, 2, 3, 4, 5, 6, 7, 8, because remember it's in the 18th group, so that means it has 8 valence electrons. And let's do 1 or 2 more here. So let's go to chlorine. So chlorine is Cl. So Cl. And Cl is in group 17. So remember 17, it's going to have 7 valence electrons. So we have 1, 2, 3, 4, 5, 6, 7. So there's chlorine. And then let's actually do helium, because like I said, that one's kind of a trickster. So we have H, E. So remember, helium, if you look at its atomic number, it's 2. So that means it only has 2 electrons. So it can't fulfill that octet of having 8 if it only has 2. So for helium, its Lewis model is going to be 1, 2. And that's it, because it doesn't have any more electrons that we could possibly use. Alright, so if you understand how to find the number of valence electrons, this is going to be pretty simple for you. And next week, I'm going to have you do an assignment over it. This week is just kind of for you to know. We'll review it next week. We'll do more examples together. So let me erase these. I'm sorry, I'm very new to this, trying to draw on slides. So you are going to have a Google form over Lewis dot models. It's going to ask you some different questions, and I will pull that up here. All right, so you're going to need a periodic table for this. Like I said, printed, awesome. If you don't, use the P table that I gave you before, or look one up. Make sure it is the updated version. It's going to ask you some different questions about like how we find the number of protons, electrons, or neutrons, how you are going to find valence electrons, the reactivity of some groups. And when you get down here, it's going to ask you how many valence electrons are in a certain element, and please put the number. So like for hydrogen, you need to look and see where that falls on the periodic table, and hydrogen is in group 1, so think of how many valence electrons it's going to have. When you put the answer in here, please do it in some sort of number form. Don't write out the number. If you write out the number, it will count it wrong. So please just put the actual number down. And that's it for this week. So this is the last video. So if you have any questions, please let me know, and we will continue on with this next week. All right, see you guys.